Hey, hi everyone. Welcome back to my channel. These chatbots are future customer service. Most of the people is gonna say yes, that's right. Today we are gonna see how to create a super chatbot for futuristic customer needs, and I'm going to show the what untold generic strategies which I'm gonna use it to build a super chatbot. So we are driving into the world of AI power customer support. Earlier, we used to have the customer support there. Most of the people used to be sit and answer whenever the call happened. But the AI is revolutionizing the customer journey with the help of like super chatbots, and that's going to help the customers and companies to give them the most complex answers and trying to give them more uh, innovative way to answer, and not only just innovative way of answer, the accuracy to answer with the relevant content to do that. So let's build a super chatbot. Today I'm going to show how to build a super chatbot, and with the help of rag graph rag. So before I'm going to walk through this architectural diagram to build a super chatbot. So I'm going to build a super chatbot, but I want to give a brief about what is RAG. So RAG is a retrieval augmented generation technique, which combines the power of information retrieval with the capabilities of large language models. So it's provide a more contextual, relevant, and accurate answers to answer the most of the queries. So today, the world is a data-driven world where business are informing, but finding the right information at the right time is crucial for making informed decisions to solve the problems. So traditional search engines are often limited. They are rely on the keywords. So whenever you search into the search engine, it might give you the keyword information, but it's missed the valuable information which is hidden within the vast database. So I'm going to build a super chatbot with rag graph rag ones, and I combine the capabilities of LLM, and I'm going to use the line chain on top of the framework. So I'm going to show how this RAG transformation can help to the enterprises to utilize the most of their knowledge bases, and the people who actually not familiarized with RAG, I recommend them to go through my previous channel, and where I explain about what is RAG and how RAG is going to work, how RAG is going to get the knowledge base informations and walk through it. So let me give a walkthrough how the architecture of the tech support chatbot. And this tech support chatbot is built on top of the vector retrieval and graph transfer retrieval and MMR based graph transfer retrieval. It means it's a combination of the three retrieval mechanism, so which help to give the more precise and accurate information. So we know vector is fast and simple, but it's limited into direct semantic similarity. So the graph retrieval is more comprehensive, considering the relationships, but it's take the computationally, it's take the time. And MMR based is more retrieval will be the document based, like which are the documents it's referred the knowledge ones. So today we are building the combination of each of them, and each one we have the different use cases, and that's where the strategies is gonna comes, right? So when we need to build uh, what kind of RAG model. So I'm going to give an example to if you want to build a simple chatbot, so which has to give you a specific information. Just give an example. How do I install software? So this can be achieved with the help of vector only retrieval. However, it has a limitations. It might not gonna understand the relationship between the concepts. That's where it's missing the semantic capabilities. And graph transfer retrieval, where I'm getting the error message invalid license key, which is specific to the license key, and it's gonna have more comprehensive and relevant answers by leveraging the relationship between the information. It might be slow, but it's gonna gives you most accurate informations to ones. And and when you are building a kind of a chatbot, it should be the combination of all those three mechanism. And I love to be into the graph TP. Graph rag is going to be a new way because it has a relationship. It's understand the context, and it's going to give a more accurate information because it has a semantic knowledge, and it knows which context it has to be passed through to do that. So today we are going to build a tech support chatbot for a software companies. So when I go and trying to access a few of the organization chatbots, and I feel those chatbots are built on a vector retrieval only, because when I asking, it is gonna gives me the workflow to answer it, but it's not giving the more relevant information when I goes deep drive into the ones. So there are scenarios where sometimes users are not just asking how to install a software. They might ask like how to fix the issue. So it has to goes back and understand the knowledge and gives the most accurate information with grounding knowledge. And grounding is one thing which we keep the number of the documents, websites, in organization which actually build a knowledge base, and we have to use the knowledge base and to use the retrieval mechanism on top of it and provide more accurate information to the users or our customers. So to do that, so I build a rack uh, DB. So what I did it right. So I try to take a synchronized HTML loader, which I collect all the website details and I store into my knowledge graph. And I've been use the LangChain framework to do that, and I've been stored into the Cassandra Graph DB. So DataDAX is built on top of the Cassandra DB. So I've taken a couple of documents. So how what it's actually doing it right? It's extract the web pages and it's take the relevant content and it's convert it to markdown, and it's create a metadata to using that, and it's leverage the LangChain and Rackstack libraries to create a knowledge graph construction. So I have a document, I have a website, and I might keep the more left hand side the knowledge information. I keep on update with the help of my pipelines, and it's gonna be run into my knowledge graph. And I use Casio IO, which is going to be a library which interacts with the Cassandra DB. So I use OpenAI to LLM as GPT 4.0 because that's going to gives you me with the prompt and lesser cost as well. So I use RAG chain and vector similarity search to retrieve the graph and store, and I use a OpenAI LLM to retrieve that information and provide most relevant information to the customer. So this is our picture view. Let's do how I can do this text support chatbot of uh, using the RAG. So to demonstrate you, I already built a couple of, I installed the knowledge stores in my notebook, and I run and I load those documents into my graph store, and with the help of like sitemap loader, which is going to load all this information and have that index of each one and keep into the my AstraDB knowledge graph. So, and I'm doing that scrap the URL sitemaps. So it's going to help to provide the grounding as well. So I take those URLs and use a HTML, asynchronous HTML loader, and which is convert my HTML and XML data into my graph DB. and then I import the asynchronous way of like using the LangChain and import most all those documents and GitHub links which I wanted to load into my uh, knowledge graph. I pass those environment details where we are using Astra DB. I have given the DB details and token, and I have provided my OpenAPI key. It's been down there, and I have given the Astra DB specific documents. I provided those documents and given the inputs, and I use import the Casio. It's a kind of like a library, and it's gonna be a help to do to from a Cassandra to AstraDB to link up those ones. And they created the batch size. So I mentioned the each batch size to detect because we have doing a combination of the documents and links. And I've created and executed the rack chains to do that. And I mentioned my GPT 40 and I asked them like be act like a technical support bot. So I given that instruction to it, and so it's understand that it's going to be act that one. So I have write the two questionnaires into the ones. The first one is like what is J vector architecture. Let me run this. So before I'm gonna go tell you right, J vector is high performance Java embedded vector search, which is designed to have the speed efficiency and flexibilities and it's gonna works for a graph-based index. So what happened whenever you wanted to retrieve the data from the graph base, so you need to have the faster mechanism to have two pass way of search mechanism to get retrieve the data into the ones. And JVector is designed easily embedded into the large scale of Java systems, and it's used to on a platform data stack to and StudyB is on top of the data stack. So I'm gonna ask the Python display. So I wanted to invoke the chain, and now I'm going to ask the vector only retrieval. So you know, right? Vector only retrieval is faster, and it's gonna give the information. So I'm gonna show you how it's gonna different the each retrieval mechanism which I use it. So let's go to the vector retrieval. So when I asked the vector retrieval, right, it's a JVector is architectural is a feature of Java languages. It deals with vector processing capabilities. So it's given a similar information. If I'm asking the same one into my chat GPT, it might provide me the similar information, but it might not gonna be help much because if you look at my context is gonna be I'm asking about JVector architecture, so it's going to give me the generalized information. So let's go with graph transfer retrieval. So you understand graph is going to work into the combination. So it has a semantic knowledge and it's understand what prompt is going to ask. So it's going to gives you more contextual knowledge compared to our vector based one. So it's understand that it's a combination like architectural design, specific technology, system J one. So it's giving the context to me that here is an official page JVector. Because if you look at that GitHub link, remember is a graph transfer retrieval. It retrieve documents using that. So if you have any documents within that, it's gonna go and see the document and it's understand and it's gonna gives me those details to me. So we can use not only the combination of one, it's gonna be we can use a different one. So now it's understand that I'm gonna do a support one. So it's asking me that like its hardware capabilities certain processor defined to handle it. So it's gonna gives me within the context of a support chatbot and it's giving that information to me. Now I'm gonna change the one, right? And if you go to the check retrieval, right? That what how this it's gonna answer this one, and it's gonna gives me, if it's referred some of the documents, it might give those documents here, but here it's more context kind of ones which has given it. Now I will change my questionnaire. So I'm gonna ask like, what vector indexing algorithm does in Astra use? So I run a specific chatbot one. Now I run my vector retrieval, and it's gonna how it's gonna answer. So it's gonna ask like, AstraDB use a two vector indexing, hierarchical, navigable, small world, and flat. These are the algorithms it's using. It's pretty fast when it's gonna gives the algorithms to flat indexing and graph based algorithms, how it's using, and which one is suited for the large data set index, and which one is suiting for the very large index ones. Now we'll go with the graph, okay? Because you know that graph is not only give that answer, it's gonna gives you most relevant answer. So now it's precisely telling you, right? So if you look at the difference between the two of them, right? So it's a generalized information, but when it comes to the graph, it says like Facebook's similarity search is developed by the Facebook, and has a library which similar search is clustering dense vectors, and it's gonna go more precise answers to us. Now let's go to MMR graph transfer. So what is gonna gives us here? So it's very precise now. It's understand like one, and it's gonna gives me Astra users withstands hierarchical navigation, small world vector indexing. That algorithm allows for the efficient, appropriate nearest neighbor searches in high dental spaces. So what is gonna go? So it's go and get to the relevant content, and it's gonna provide the answers to it. And when you go and check the retrieval results, so it's more important. So whenever we do it right, we should know like from where it actually get those information. So it's gonna goes from each of the metadata information. If it's I train it again, right, on top of this data, it's gonna provide us the metadata from where the grounding is gonna showing that details. I hope you enjoy this uh, session. So it talks about more into the graph RAG uh, model, and if you like it, you just like share it to the most of the people, and you let me know which are the more content you would like to hear from me, and I'm happy to share with you guys. And thank you so much for watching it.